Hello everyone, my name is James Swinehart, and in my research project, I evaluated consumers' willingness to pay for electric aircraft using a stated preference survey. To introduce you to this topic, it is important to know the context behind it. In recent years, the majority of consumers and governing bodies in the United States have begun to take action towards a more sustainable future. Because of this, the commercial aviation industry, including airlines and aircraft manufacturers, have begun to make plans towards making sustainable changes to their businesses. In order to ensure that the commercial aviation industry can push towards its goal of a sustainable future, sustainable innovation is needed. That's where electric aircraft come in. Electric aircraft are a slower, smaller, zero-emission alternative to standard short-range commercial aircraft that you would find in regional markets. Prototypes of electric aircraft are already making their way into markets today, and because of their sustainability, their success is a crucial step towards a more sustainable aviation industry. Therefore, I created the research goal of determining how different factors like price, timeliness, and comfort affect consumers' willingness to pay for electric flights, as ensuring a high willingness to pay is key to the success of a new product. When I first looked into pre-existing research on this topic, I found that while some cornerstone works in the field provided good models to base my research on, their conclusions alone were not enough to determine my own conclusion of ensuring a high willingness to pay for electric aircraft. The first cornerstone work that I observed was by Connor Rice and his colleagues at Embry-Riddle Aeronautical University. They used a stated preference survey to determine how different sustainable fuel alternatives affected willingness to pay in the aviation industry. The result was that consumers exhibit more willingness to pay for sustainable fuel options. While this source was useful in modeling my methodology later on in my research, its suggestion that consumers would pay more for sustainable fuel alternatives was not enough to conclude my project as a whole, as electric aircraft are a complete overhaul to the flying experience and could have different impacts on willingness to pay than a simple switch in fuel type. Another cornerstone work I observed was by Kuhlthau and Jacobson from the University of Virginia, who found that consumers exhibit less willingness to pay for longer, slower flights. This further strengthened the need for my research, as electric aircraft are slower than standard aircraft, which could contradict the positive willingness to pay brought by electric aircraft being a sustainable alternative to standard fuel. It could also affect willingness to pay in ways different from how a sustainable fuel alternative would. Similarly, my third cornerstone work that I observed by Kevin Balcombe in the Journal of Air Transport Management found that consumers exhibit less willingness to pay for smaller aircraft. Again, this was contradictory, as electric aircraft being smaller than standard aircraft would offset any positive willingness to pay change brought by them being a sustainable fuel alternative. Because of these contradictions and insufficiencies in pre-existing research, it can be seen that a gap exists in market research pertaining to electric aircraft. That's where my project comes in, because this gap needs to be addressed and can be addressed through my research goal. Because ultimately, my research will help to determine how successful electric aircraft may be and address any contradictions or insufficiencies in pre-existing research. And ultimately, my conclusions may help to find how the aviation industry could address its sustainability problem. After analyzing over 50 sources pertaining to my topic in my literature review and basing my research goals upon the cornerstone works that I discovered, I hypothesized that if there were no differences between the attributes of an electric flight and a standard flight, then a majority of consumers would choose the electric option. I also hypothesized that if price and time increase and comfort decrease in an electric flight, then willingness to pay for those flights will also decrease. To answer this research goal, I found that the best methodology pertaining to my topic was the stated preference survey. In this survey, consumers are given two options with differences in things called attributes. For example, in my study, these attributes were price, time, and comfort. Consumers then pick the option that they find most desirable after comparing their preferences to the attributes of the options in the survey. After the results are submitted, researchers can see which attributes matter most to the consumers when choosing something by analyzing the option that they chose. I chose the stated preference survey for two main reasons. For one, the survey is widely used in willingness to pay research, and specifically in the aviation field. An example of this is the Connor Rice study, and also a study by Sinanu Ashiobor and his research at Virginia Tech. In this study, he used a stated preference survey to determine how willingness to pay changed when consumers were presented with different aircraft attributes and the choice of purchasing an airline ticket. The second reason was that the ability of stated preference surveys to create valuable results in hypothetical markets makes it the perfect choice for my topics, as electric air travel in mainstream markets is still just a hypothetical. Here's an example of what my stated preference survey questions looked like. Respondents were given a choice between a standard flight and an electric flight, and in this case, the price attribute was varied. Therefore, respondents could choose the option that they preferred, and I was able to determine how price affected that choice. After conducting my survey, I analyzed my results. I noticed that the participants for my results were skewed based on gender, as I received 266 male responses and 108 female responses. To ensure the validity of my research, I followed guidance from Princeton University professor Matthew Salganik and stratified my results into a male group and a female group. I then found the mean willingness to pay across attributes by giving a response choosing the electric option a score of 1 and a response choosing a standard option a score of 0. This allowed me to find an average for each attribute on a scale of 1 to 0, with 1 indicating high willingness to pay and 0 indicating low willingness to pay. I then used an analysis of variance tests, which compared all of my responses to determine if there was a statistically significant difference in respondent choices as attributes changed. For both males and females, the test found statistically significant p-values of less than 0.5 for all attributes, indicating a 95% significance for all of my results. As you can see for males, willingness to pay was high for electric aircraft when there were no differences in price, time, and comfort from standard aircraft. However, the graphs demonstrate that this willingness to pay decreased as price increased, time increased, and comfort decreased. You can also see that time had the biggest impact on willingness to pay, as it resulted in the lowest willingness to pay score as time increased, and comfort had the lowest impact, as it resulted in the highest end willingness to pay, even at the lowest comfort level. The same trend could be seen in female responses, with there again being a majority of respondents choosing to fly electric when there were no differences in price, timeliness, and comfort in comparison to a standard aircraft. Like the male group, willingness to pay fell when prices increased, flight times increased, and comfort decreased. Time, again, was seen to have the highest impact on the willingness to pay drop, and comfort the lowest. This can be seen on the graphs on the right, where time resulted in the lowest willingness to pay score for all attributes at its highest level of time increase, and comfort resulted in the highest level of willingness to pay over all attributes, even at the highest level of comfort decrease. So what do these results mean? In general, we can see that there is a statistically significant majority of both males and females who are more willing to pay for electric aircraft than standard aircraft when there are no differences in the attributes for these flights. And in both genders, this willingness to pay fell as prices increased, time increased, and comfort decreased. This shows that both parts of my hypothesis were true. For one, these results show both airlines and aircraft manufacturers the attributes of the flight experience that need to be taken into account when evaluating electric aircraft options and implementing them into their markets. They show how things like timeliness and price should be given special attention over things like comfort when introducing electric aircraft to consumer markets. The results also show that if commercial aviation industry is to make the electric aircraft flight experience the same as today's standard aircraft flying experience, the majority of consumers will gladly be more willing to pay for electric aircraft and fly on the electric flights. As a whole, this study was effectively able to determine how price, time, and comfort affected willingness to pay for electric aircraft. And as a result, this study was able to determine that electric aircraft can be successful and yield high willingness to pay as long as the commercial aviation industry takes measures to ensure that things like time and price are given special attention, and as a whole, make the electric aircraft flying experience more similar to today's standard aircraft flying experience. With these considerations in mind, the commercial aviation industry can effectively use electric aircraft as a way to take a step towards a more sustainable future. Thank you.